Hello everyone, hope all of you are doing great. Ashutosh Bhattodekar once again, and this time with a new topic which I love the most, software testing. And I have decided to create a few videos on software testing more aligned with the ISTQB syllabus. So whether you are aspiring for ISTQB Foundation or ISTQB Advanced or Expert level certifications, I'm sure these videos will be of help to you. So the first video which I have decided to create is on the 7 fundamental principles of software testing. So whether you are into manual testing, automation testing, whether you are a test lead, a tester, or a test analyst, I'm sure each one of us needs to understand these fundamental testing principles. And it's not just about the theoretical aspect of it, but the real-time practical application of these principles is something what we all need to understand. So in this short video, I will cover the 7 fundamental testing principles and I'll try to give examples from our day-to-day life. So let's start the video. The first principle we have is testing shows the presence of defect. Now, many of us have got a very strong misconception that testing actually is going to prove that there are no defects in the system, which is not correct. Testing merely shows the presence of defect, and once you rectify the defects, there is no guarantee that there won't be any further defect. The very fundamental premise of doing software testing is that yes, there are defects in the system. Because we have found these defects in the system, we are able to rectify them early. And one of the testing principles related to this is, of course, early testing, wherein I will talk about this particular point in detail. But the very premise of doing testing and identifying defects is that we catch the defects early, thereby we increase the confidence of our product working better in a real life environment. Okay, but it does not mean that there are no defects existing in the system. In fact, even after the product has gone live, there could still be some defects which could be found out. So that's principle number one for you. Testing shows the presence of defect, not the absence of defects. Let's move on to the second principle. The second principle is exhaustive testing is impossible. So believe me, friends, however time you have, however effort you get, you will never be able to do exhaustive testing. And what do we mean by exhaustive testing? It's all about testing all the possible permutations and combinations. As you can see the classic maze diagram there, right? I mean, there's one path, but if you want to test all the possible combinations, it might be a Herculean task for us to do that. At the same time, I cannot say that I will do zero testing. That would be a major disaster. So what do? I establish a balance between exhaustive testing and no testing. And I apply techniques like risk-based testing strategy to optimize the test cases which I would like to utilize. Now, I do have a video on risk-based testing strategy. I'll be putting the link of that video in the description box. You can also see on the top right corner, the link would be appearing now on risk-based testing strategy. Do watch that video to know more about how do we devise a risk-based testing strategy approach. All right, moving to the third principle. The third principle is about early testing. As the old adage says, right, a stitch in time saves 9. If I catch a defect early, it'll be much more cheaper for me to fix it rather than if I catch it later during the life cycle of a project. We have this very classic curve which talks about where did the defect originate and where was it caught. Ideally, the phase introduction and the phase detection of a defect should be same. That will be the cheapest what you can spend to fix a defect. However, if there's a big difference between the phase in which the defect was injected and the phase in which it was detected, obviously it is going to cost you a lot to rectify the defect. So one very contextual example which I have shown here about what related to that concept of stitch in time saves 9 is the early testing principle. If you look at this picture on the left hand side, of course, is an ideal state where there is no defect. That does not happen in a real world, but you capture the right set of requirements, you design as per the requirement, you code it, and you deploy, test it and deploy it into the live environment. That is all green what you see. But imagine that you capture the requirements correctly, you design it as per the requirements, but the problem is in build. when you're building it or when you're developing it, that's when the problem is. This kind of a defect would predominantly be found during integration testing. The third tower in this same picture talks about the defect being injected much more earlier, right? I mean, in the design phase of the project, and the when it is detected probably is when the product is ready for system testing. So as you can see, the injection versus detection, there is a huge gap in this. And in the fourth tower, the defect got actually injected in the requirement itself, but it was detected very, very late, probably during the UAT or the user acceptance testing. And as I said earlier, the cost of fixing defect, as you can see in that curve, is going to exponentially increase. The earlier you find a defect, the cheaper it is to fix it. So this is principle number 3 for you. Early testing. Catch them early. A stitch in time saves 9. Moving on, let us look at the fourth principle of software testing. And the fourth principle of software testing is all about defect clustering. And the picture which I have tried to depict here is of a city which is having a very heavy traffic. Now, if you look at any city, there are some traffic patterns which are there. Usually, we'll find the morning 2.5 hours or 3 hours will be the rush peak period. Similarly, the evening time will be a rush peak period. So this is exactly the analogy of defect clustering. Out of multiple modules in your application, you will find that there will be 3 to 4 modules which will be having a maximum concentration of defects in them. So there'll be a lot of defects found in those 2 or 3 modules which are there. So if we attack them, if we attack those modules, if we rectify those modules, and if we make them clean of defects, a major part of your defects would be reduced. And one analogy for this is the classic 80-20 Pareto principle. 80% of the defects in top 2 or 3 categories of the defect type. So that's defect clustering for you. Next, principle number 5. Principle number 5 talks about testing being contextual or context dependent, which means as a test lead, as a test analyst, as a test manager, the level of testing needed, the rigor of testing needed, the formality of documents needed to a greater extent depends on the application being used. So if it's a high security application like a banking application, I would have a different mix of testing which is there. More focus would be on performance testing, security testing, port testing, etc. Of course, besides for functional testing also. But if it is a game site, if it is a kids game site, the focus would be more on usability, user acceptance testing, how attractive the product is. All those things will be a part of my testing piece. Again, I'm not saying that we will skip some key elements. What I'm trying to tell here is the percentage of testing will vary. The focus percentage will be more on security and functional testing as far as the banking application is concerned. It will be more on usability and I would say on the attractiveness of the software if it is a kids software or a cartoon site which I'm developing. So that's principle number 5 for you. Testing is context dependent. Moving on, 2 more principles remaining. Principle number 6 is about what we call it as pesticide paradox. Now, this is a very interesting principle what we have. Pesticide paradox talks about the fact that if I run the same test cases again and again, they are not going to find new defect, right? Similar to a pesticide, right? If you spray a pesticide first time, second time, or probably third time, it will catch insects, but over a period of time the insects also will get immune to it. And the pesticide until unless the pesticide dosage is altered, they won't be able to catch the insects again. Similarly, our test cases have to be refined. They have to be redesigned over a period of time. If I try to run the same test cases again and again, it might result in no defects being found. So that's pesticide paradox for you. Make sure you keep on upgrading the test cases. You try to attack new areas of the software. You try to redesign and reinvent the test cases so that more defects can be found in the subsequent run of the test cases. All right. Moving to the last principle of software testing, absence of error fallacy. Now, a very interesting example again, maybe you got a requirement for developing a wristwatch. You thought that this is what the customer needed, a wristwatch which shows time. But just because there are no errors in this wristwatch is showing correct time, doesn't mean that the customer is going to accept the product. Many times we have this misconception that why is the customer rejecting my product? Everything is working, right? Things are working fine, there are no bugs. At least during testing we did not find any defects as such, yet the customer refuses to accept the product. The reason for this could be that we have clearly not understood the requirement. Okay, or the system is not usable enough. It is not usable enough, or it does not meet the user's needs and expectation. Probably this is what the user wanted at the end of the day, and he or she was unable to articulate the requirements in the early stages. So absence of error fallacy is all about making sure that just having zero defects. In fact, zero defect is a misnomer, as I told you earlier, right? Testing does not show the absence of defect, it shows the presence of defect. Let me put it in another way. Just because in this particular test cycle run you do not have defects, does not mean that the product will be accepted by the customer or end user. He or she might have expected something else, which our requirement gathering team, our design team may not have understood it well. So, my dear friends, these are the 7 key testing principles which I have tried to cover in this short video. Do let me know if you like this video, and based on your feedback, I'll be covering more topics on testing as we go along. Do like, share, and subscribe to my YouTube channel. This is Ashutosh Bhattodekar signing off for the moment. Thank you very much and have a great day ahead.